Welcome. This video covers the common data object called a vector in R. Now, we've talked about the idea that we have this raw data that we want to import into R. And so we need to understand how R commonly stores data like that. And so there are 5 very commonly used data structures in R, and we're going to cover 3 of them. So there's the atomic vector. That's what we're going to start with. This is the sort of most simple, the simplest type of object that we can deal with. It's one-dimensional, so there's an ordering in one dimension. There's a first element, a second element, a third element, that kind of thing. But everything within that vector needs to be of the same type. So we have to have homogeny within there. So everything within there is a number, or everything within there is a character string, that kind of thing. The matrix and array are just the 2-dimensional and n-dimensional extensions of that idea. Those do get used, but not in the sorts of data sets that we're going to use, so we're going to sort of skip those and jump straight to looking at the data frame after the vector. So the data frame is really the most useful way to store data commonly. And that's a rectangular object, so it's 2-dimensional. It has rows and it has columns, but each one of the columns can be of different types. So you can have a numeric column next to a character column next to a numeric column. And so it's the most useful type of object for storing basic rectangular data. But then lastly, we're going to look at a list, which is a one-dimensional thing. So again, ordering in one dimension, a first, a second, a third thing. But then each element itself can be a completely different type of R object. So a super flexible way to store data. All right, let's get into this vector and understand it a little bit more deeply. So a vector is just this one-dimensional group of elements that has an ordering. And so here's an example of a numeric vector up top. You can see that there is a first element, a second element, a third element, a fourth element, and a fifth element. So there's an ordering to these things, but each one of these things is numeric, right? So they're all of the same exact type. Similarly, down below, we have a character vector. So character vector here. This has cat as the first element, dog as the second, bird as the third, and frog as fourth. So again, one-dimensional, and everything within it is of the same type. How do we create these vectors? We've already seen this C function used a little bit. So C stands for combine, and it is a way to manually create a vector. What we're doing here is we're going to use this storage arrow we talked about before. This is going to say, in the object X, store the result of this function call you see over here. So I want to use C to combine together the number 17, 22, 1, 3, and minus 3 in a vector in that order. And so when I run X later on, I get exactly that output out. So this is now a vector with those 5 elements in it. Similarly here, I've used the storage arrow to say save in Y, the result of combining together in a vector, cat, dog, bird, and frog. And so again, this is a character vector, and character strings need to be in quotes. So you can either use double quotes or single quotes. When you're creating them, generally speaking, R can use either one, as long as you use the same ones. Now, lots of other functions also output a vector. So C is used to manually create a vector. But functions like sequence get used all over the place to create vectors as well. So what does sequence do? Well, it takes in different inputs. So one option for using sequence here is to put in a from argument, a to argument, and a by argument. So if I put from equal 1, I put 2 equal 5, and by equal 1, I'm going to get out a vector 1, 2, 3, 4, and 5. So very useful function for creating a sequence of numeric values. Here are 2 ways to create the exact same sequence. So sequence actually has different arguments that you can call depending on how you want to specify the sequence. You can either do from and to followed by length, or you can do from and to followed by. And both of these 2 function calls give the exact same vector, 1, 2, 3, 4, 5. Again, it's important to understand what type of output, what kind of object we're getting from these function calls, and that structure function that we looked at in the previous module, previous videos, is super useful for this kind of thing. So if I look at the structure of this V object I created up here, this object is numeric, so it has numbers in it. It has 5 elements, and here are the 5 elements listed out. Sequences get created so often in R that there's actually a shorthand operator to create sequences, and that's the colon. If I do 1 colon 20, that's a shorthand way of saying sequence from 1 to 20 by 1. And one interesting thing that you need to know about R is how it does math on vectors and matrices and numeric columns of data frames and that kind of stuff. And so if I do something like 1 colon 20, the output of this is this vector 1 to 20. If I then divide that by 20, what it does is it divides each element by 20. So 1 colon 20 gets evaluated first. And then the math happens on that vector. So the math is going to be done element-wise. Each element will be divided by 20. If I do 1 colon 20 plus 1, it's going to say, oh, I have a vector 1 to 20, and then I'm going to add 1 to each one of those elements. So generally speaking, R is going to do math element-wise on vectors, matrices, numeric columns of data frames. All right, we now know how to create our own vectors with C. We know the sequence function that automatically will create sequences of numeric vectors for us. Let's say I already have a vector. How do I actually just return certain pieces of those? How do I get like the first and the fifth elements just returned to me? Well, if I want to return elements of a vector, I can just use square brackets directly after that object, and then within the square brackets, I put which objects I want to return. So for instance, there's this letters built-in object, so it just has the lowercase letters A through Z. And if I want to return the first element of that vector, I would just do letters, bracket, immediately following letters, and then put 1 in there. Remember that R does start counting at 1. If you come from other programming languages, that might be very weird to you. Most other programming languages start counting at 0. But we're going to start counting at 1. So if I want the first element back, I just put in 1 there. If I want the 26th element, I just put in 26. Not too bad. What's kind of great is that you can return more than one element at a time, which is, of course, kind of useful. So remember that 1 colon 4, what that's going to produce, it's the same thing as saying I want to create a vector 1, 2, 3, and 4 put together. So what we're saying here is from the letters object, within the brackets, I'm saying these are the things that I want to return. I want to return the first, second, third, and fourth elements. And so that's what I get out here. Similarly, here I'm going to create my own sequence, 5, 10, 15, 20, and 25. So I'm going to return those from the letters object as well. Not only that, but I can create an indexing vector, which is what we would call this thing. So I'm going to actually create an R object called X that has the vector 1, 2, and 5 in it. And then I'm just going to feed that indexing vector directly into the square brackets. And when I do that, I get returned the elements corresponding to that indexing vector. So a very common way to index your elements. You can also return everything except certain elements, which is kind of useful. So if I put a minus sign in front or a negative sign in front of my indexing vector, it will return everything except those elements. Here I'm going to say from the letters object, return everything except the first, second, third, and fourth elements. Similarly down here, I have this X object. I'm going to say everything except the things corresponding to X. All right, let's jump into RStudio and play around with vectors. All right, here we are in R. Let's go ahead and play around with vectors. I'm just going to continue the previous program that we had. I'm just going to put a comment here to say that this is going to be where we're going to do our vector practice. So let's see, what do we got? We already have a vector, right? MyUnif is a vector with 100 random values in it. And what we might want to do would be maybe just grab the first 10 of those things. So let me do MyUnif and then 1 colon 10. Remember what 1 colon 10 does. It creates a sequence of values from 1 to 10. If I put that within my square brackets, I'm saying return just the first through 10th values. Okay, cool. We could also say, hey, let's get back the 91st through the 100th values. No problem. That's the last 10 values of my vector. There are lots of other functions that you can work with. Basically, any type of operation that you want to do in R, there's probably a function that will do it for you. So maybe I want to sort my random values. I can actually run the sort function. So sort is a base function. The help pops up here in RStudio, which is nice. It sorts a vector or factor into ascending or descending order. So if I just say sort, and then I say parentheses, I give it the argument I want, which needs to be whatever X is. X is the object I want to give it. So let me give it MyUnif, the 100 random values that I had, and let me sort that. You can see over here that we have sorted those values from smallest to largest. But you might say, hey, if I look up here in my environment, MyUnif is still not sorted, right? 0.4 is the first element, 0.64 is next, 0.94 is next. That's not sorted. And that's because we did not overwrite the MyUnif object, right? What we did here was we ran sort on MyUnif, evaluated that in the console, it spit out the sorted vector, but we didn't save that result anywhere. So all we really have from this function call is the result we see in the console. We can't use that now anywhere else because we didn't save it. What we might do instead then is actually save this as an object. So I say sorted unif, store the sort of those values. I'll send that to my console, and now you see I have a new R object called sorted unif that has the values from smallest to largest. Great. Well, with the sorted values, maybe I want to do something like just return the 10 smallest values. So I might go sorted unif, and let's actually create indexing vectors. So let me go with index 1. I'm going to store 1:10. Let's also grab the last 10 values. So I'll do index 2 is 91 to 100. I'll create new R objects corresponding to those. I need to submit these to my console. Notice in my global environment, I'm getting 2 new values. Cool. Now when I do my sorted unif, what I can do is index 1 in brackets, and that's going to give me my first 10 values. And then if I did the same thing, sorted unif, and I did index 2, it gives me my last 10 values. I could also put those together, so maybe I'll create a new thing called first last. Remember that C allows us to combine together different elements of the same type. So I'm going to combine those first 10, the smallest 10 values, together with the last 10 values, the largest 10 values. Okay, so we can combine these function calls together. Again, what this is doing, I'm going to store in a new R object called first last, combine together the sorted unif indexed by the first indexing vector, along with the sorted unif values indexed by the second indexing vector. So I submit that to my console. Notice that this has 20 elements in it, and these look like the smallest ones to start with. Just to double check that that gives us what we think it probably gave us, let's go hist first last. So we'll just create a basic histogram of these random values. Sorry about that. Here we go. And so we see that all the values are either really small or really big, which is what we would expect. All right, hopefully you're getting excited. That is our first major type of object that we're going to store data in, the vector. Vectors are these one-dimensional things, ordering in one dimension, and they're all of the same type. We can really think about vectors as a building block for our data frames, which are going to be the most useful objects for actually storing data sets that we think about analyzing.